hold on, did I type this in wrong? X plus 1 equals x cubed minus 2x minus 5. X plus 1 equals x cubed minus 2x minus 5. Okay. Solution is we're going to be where these two intersect. Well, notice that the roots of this thing, no, here we have a real solution, 2.355.
Yeah, that's what I got.
That's what you got also?
Mm-hmm.
Not quite sure why it doesn't show us that curve.
The curve is like I did on my calculator.
Yeah, well, here's the number line, so they're plotting it, the solution right there, 2.3553. Okay, and if we turn this into a single function, let's say I want to subtract this, and then I want to add this, and then I want to add the 5. Okay, so now if we plot this whole thing as a single function, should cross the x-axis in one spot only,
Mm-hmm.
and that will be its 0. Right there.
Yeah, that looks right.
Same number, 2.355.
Okay.
Okay? So you got the technique of what we do?
Yeah, it makes
Just
that's
move
pretty.
everything to one side of the equation and go from there in order to plot it as a single function. Okay, 50. Do you know how to put absolute value into your calculator?
Yeah.
Okay, let me do it while you're doing it
Okay.
and see what we get here. Okay. Again, they give us two different graphs. One is 2x plus 3, the absolute value of 2x plus 3. The other is 4 minus absolute value of x plus 1. We can readily see where those intersect. That's about, you should get a number minus 2.7 approximately. 2.66. Yeah, no, that's right. That's the x. What they're asking here is the x value. In other words, we're trying to solve for x. So we want the x value of that point right there. According to Wolfram alpha, that's minus 2 2/3. And then the other x value is 0. Notice that when x is 0, I have 3 equals 3.
Mm-hmm.
Okay, did you figure out how to do that using intersect?
Yeah, so you just like put it on the point and then.
So when you use the intersect, you don't have to label left and right. You just put it on the point and hit trace,
Mm-hmm.
and it gives you the intersect value right away?
Yeah.
Oh, okay. So that's one of the easier things to do.
Yeah.
Okay, now to plot this as one function only, I'm going to move the left absolute value over to the right. So I'm just going to cut, take away that equal sign, put a negative sign, and paste. Now that is one function that's equal to 0. Because once I took that away from the left side, what was left behind was 0.
Mm-hmm.
Okay, so this will give me only one function. They'll show me the imaginary and the real part of it. No, there is no imaginary part. There's just a real part. So wherever this function crosses the x-axis is my solution. Well, there's the minus 2.66, and there's the 0.
Okay. Okay. All right.
All right. Let's put in 51.
Okay.
We did some of these yesterday. Sketch a graph. Well, when they say sketch a graph, that means you can use your calculator, right?
Yeah.
They don't want you to have to sketch these manually, I'm gathering.
No.
Okay. This is one function only. It's not something equal to something else. Okay, so if I look at that graph, let's look at this bottom graph here. Where is it decreasing? On what interval? In fact, I guess you're going to need to figure this out on your calculator.
Yeah. Well, what do you look for a certain point that it's like that point right there?
Well, it's decreasing from negative infinity all the way on the x-axis, negative infinity to that point right there.
Okay.
Now, figuring out that point on your calculator, it looks to me like this is a horizontal line.
Yeah.
So if you try to figure out the minimum value and click there and click there, you'll get that value.
Okay.
You'll get that y value. Can we tell what it is up here? Looks like it's 1.
Negative. Yeah, well, it's -2.
Looks like this y value is 1. Oh, I see. That's -2 there.
Yeah.
Okay, so it's decreasing from negative infinity to -2. It's constant from -2. What's this point here?
1 second. It is.
I'm not so sure that's that easy to find on your calculator because the minimum is a range of x values.
Yeah, it's 1.1 or 1.2.
Okay, and then it's increasing from 1.2 to positive infinity. So you have 3 intervals. You have the decreasing interval, you have the constant interval, and then you have the increasing interval. Now, to get the exact x value of that, doesn't give it to me here. You sure you know how to get the exact x value of that point right there? You're right. It looks like it's about 1.2.
Yeah.
But you're going to need that exact value. This exact value looks like it's at 2, -2 exactly.
Yeah.
But this exact value, I don't know what that is.
I don't know how, because you don't know exactly if you're on like the
No, exactly.
on the right point, you know.
I'm trying to think of that calculator. You can do minimums, you can do maximums. If you try to find the minimum,
Yeah.
and you click there to the left and then to the right of that to the right, boy, it's liable to still give you any x value. It's not necessarily going to give you that x value.
Right. Maybe my teacher will be understanding and know that we can't get it exact.
Well, there may be a way to get it exact. I'm not sure how I would do it though.
Yeah, and she doesn't like said anything.
Okay. Well, let's go on to another one here. Now, notice when I put it into Wolfram Alpha, I just put that whole expression, but it really is the same as this 52. In other words, if I want to put 52 in, I could say y equals all this, or I could just type in 0.5 times quantity x plus 2 raised to the 2 power minus 1. In other words, it interprets this as y equals.
Okay.
Okay, and that's what we're looking for, is that. Okay, let's look at it. Now, this should be pretty easy to do without using the features of your calculator.
Okay.
Where is it decreasing? Always start from the left, I think. If you're trying to define a function as increasing, constant, or decreasing, where is it, since we're coming from the left, it's decreasing from where to where?
Negative infinity to like 3.5, it looks like.
Not
Or is it
it's not to here. It decreases all the way to this point here, the vertex.
Okay.
Where's the vertex of that thing?
-1.
It's -2, -1.
Okay.
In other words, the coordinates of this point right there, this is in vertex form. Remember, vertex form is x minus h plus k. Well, if x minus h, that means h is -2 for us to get an x plus 2 here. So h is the x coordinate of the vertex. That is -2. So it is decreasing from negative infinity to -2. And it's increasing from what? It's not constant anywhere.
From -2 to infinity?
Yes.
Okay.
And both of those would have brackets. It would be decreasing from parentheses negative infinity right up to 2 bracket. I guess that's a bracket. No, you know, that's probably a parentheses. That's probably a parentheses. Because right at -2, it's actually flat. It's 0. The slope of the tangent line would be 0, and it would no longer be decreasing. So it would be negative infinity to -2 parentheses, and then parentheses -2 to positive infinity for increasing.
Yeah, it would be.
All right. Should we do more 53 and 54, or you want to cover odd and even stuff?
Yeah, let's cover odd and even.
Just let's make sure we get to everything.
Yeah, I agree. Because I know how to get odd and even looking at a calculator, but I don't know how to really solve it like algebraically.
Well, I can show you how to do it real quick. Real easy.
Okay.
The definition of even is f of minus x equals f of x. The definition of odd is f of minus x equals minus f of x. So if I had f of x equals x, what's f of minus x equal?
-x.
Which is negative f of x. So is this even or odd?
Even?
It's odd.
Or it's odd.
Notice that when I plug in minus x, that's always the test, you plug in minus x for x, that you get not the same function. I didn't get x. I got negative x, which is negative f of x.
Okay.
So that's the key. Let's try another one. that I'll make up. F of x is x squared. Is that odd or even? What happens when you plug in minus x? What do you get?
An even.
You get x squared,
Right.
which is same as f of x. Since f of minus x is equal to f of x, it's even. Notice that it has an even exponent. That usually makes it even.
Okay.
Unless it's in combination with an odd exponent, and then it wouldn't be. But let's go through these. How about this first one? Y equal 2x to the fourth.
It's even.
It's even because when I try f of minus x, I still get 2x to the fourth. Okay, let's try 56.
So you plug in minus x.
Right.
And you'll still get regular x, so it's even.
Well, let's see. If f of x, I prefer to call it f of x as opposed to y because it's easier to relate to that way. So what is f of x? What is f of minus x?
3 over 1 plus negative 2x squared.
Which is equal to?
3 plus x squared. Or 1 plus x.
So it didn't change.
Right.
That's the same as f of x. Exactly. It has to be exactly the same.
Okay.
Since f of minus x is the same as f of x, that's even. Can't necessarily look at just the exponent there, because as these get more complicated, that won't always be true. Although, yeah, here's one. Well, let's look at 57.
Okay.
So f of x is 2x cubed minus 3x. So what's our first step?
Plug in negative x, or
Figure out what f of minus x is.
so it's 2 negative x cubed minus 3 times negative.
Let's figure this out.
So it would be minus x cubed minus or plus 3x.
Now that's what f of minus x is equal to. Is that the same as f of x?
No.
Might it be the same as negative f of x, which would make it odd?
Yeah.
Yeah, because if I factor out this negative sign, I'm left with 2x cubed minus 3x. So it's exactly negative f of x.
Okay.
So
And how do you know when it's neither?
when it's not either f of x or negative f of x. Let me give you an example of one that's neither. Same problem, make that x squared.
Okay.
Notice that it changes a lot. Just by making it x squared, this now turns into minus 3x squared. In other words, this minus sign stays there. This minus sign goes away because we're squaring it. So now we have minus 2x cubed minus 3x squared. That's neither f of x nor negative f of x. I could factor out the minus sign so that I have 2x cubed plus 3x squared, but notice that that's not f of x. So I would not be able to say that that's neither odd nor even. In other words, it's only odd or even if you can make these top two statements. It's even only if f of minus x is f of x, And it's odd only if f of minus x is equal to minus f of x.
Okay.
All right. Let's see if they've given you one that's neither. And look at the last one here. Yeah, they have. F of x equals x over x squared plus 4. Take it from here.
So it's negative x divided by negative x squared plus 4.
Now when you say negative x squared, it's not this.
Mm-hmm.
It's this. In other words, you kind of need to say the quantity negative x squared.
Okay.
In order verbally to be able to distinguish minus x squared from the quantity minus x squared, because they both have different meanings. One's going to end up x squared, the other's going to end up minus x squared. In other words, this is not the same as this.
Mm-hmm.
This is still minus x squared, whereas this becomes x squared.
Right.
Okay. So now let's simplify and see what we have. See if we've got either f of x or x. Well, this simplifies to this. And notice, compared to this function over here, that is negative f of x, isn't it?
Mm-hmm.
In other words, I can take the negative sign out, leaving behind everything else.
Mm-hmm.
And this was f of x. So since it does equal minus f of x, it's odd.
Okay.
You can't always tell by first inspection. In other words, I wasn't sure. I thought this was going to come out to be neither, because I figured we would change the sign on that and we wouldn't change the sign on that, but that's exactly what we want for it to be odd. So, all right. Let's look at the next page. Not much on this, but doesn't look like we need much. Not often that somebody sends me something and I recognize my own handwriting. Up there. No, seriously, that's a very rare event. I don't think I've ever had it happen. Oh, let's see. Yeah, we don't need that there anymore. You know what the test is.
Mm-hmm.
So, if f of x, oh, let's see, this is a different question. We need to identify points of discontinuity, holes, and vertical asymptotes of each. We got 10 minutes. What's the first thing I got to do to this?
Factor it.
Okay. How's it factor?
The top is x. It's going to be x plus and minus.
Okay, this plus sign means the two signs have to be the same.
Oh.
It's got to be plus plus or minus minus. Look to the middle term. Since that's minus, it has to be minus minus. Notice you cannot multiply those two numbers and get a plus 8 unless those two signs are the same.
Right.
If they're different, we're going to have a negative 8 there. So what factors add to the number 6?
4 and 2.
The bottom one. These
Um,
have to be opposite signs because of that negative.
Right.
And now we want factors of 2 that subtract to the number 1.
2 and 1.
And 2 goes with, that's the bigger factor, so it goes with that sign, which I just screwed up. There we go. And there's 1. So we immediately see we can cancel that out, but before we do, let's note where our restrictions in the domain are.
So -1 and 2.
X cannot be -1 or 2. Okay? Now, so we don't know yet whether that's going to be vertical asymptotes or holes. They're going to be one or the other. So the next step is to cross out what we can cross out. We're left with x minus 4 over x plus 1. Can't simplify that anymore at all. So now, where are our vertical asymptotes? First step.
-1.
Where's our horizontal asymptotes?
1.
They didn't ask for horizontal asymptotes. They just asked for vertical. But, yes, 1 because the ratio of the coefficients, the x power is the same as this x power. The ratio of their coefficients is 1. So there's my horizontal asymptote. I know this thing's going to go like this and like this. The only other thing that I don't know is that hole has to go at 2. Right there.
And then how do you find the discontinuity?
Okay, so we found the vertical asymptotes and the holes. The discontinuity is wherever you have to pick up your pencil. Where do you have to pick up your pencil? For me to have drawn that function, where did I have to pick up my pencil?
Is it the asymptotes? So -1 and 2?
From negative infinity, I have my pencil all the way on it, but once I get down there, I got to pick it up. I got to pick it up right there. So there's a discontinuity at -1. And when you're defining your discontinuities, you're defining it on the x-axis. You're not defining the y value, you're defining the x value. Okay. Where else do I have to pick up my pencil?
1.
2, plus 2. In other words, at these 2 points right there.
Okay.
X can never be equal to -1, and it can never be equal to 2. There's no way to draw the function through those 2 points.
Okay.
X can't be either of those values ever.
Okay.
And that's what makes for a discontinuity.
Got it.
All right. Let's look at 60. What do I need to do to the bottom?
Factor.
Now what? What are my 2 trouble points? Let's call them trouble points instead of vertical asymptotes or holes.
Is it 2x and -3?
Trouble points are going to be whatever makes the denominator 0. -3 was correct. What else makes the denominator 0?
0.
That's a trouble point. In other words, this means that x can never be equal to either of these things.
Okay.
Regardless of how we simplify it. Well, how can I simplify it? These kind of problems, you're always going to have something in the numerator that cancels out with something in the denominator.
Oh, the x.
Okay. So I'm left with 1 in the numerator, because all I did was I divided top and bottom by x.
Okay.
The denominator, I'm left with 2 times the quantity x plus 3, so we'll just make it 2x plus 6. So there's my function. So where's my vertical asymptotes? I know those are 2 still trouble points, but only one of them is a vertical asymptote. What's that?
Is it 1/2?
-3.
Oh, vertical, yeah. Sorry, I was thinking of horizontal.
Okay. As far as the horizontal asymptote goes, you bring up a very good point. Is it 1/2?
Or is it 0?
It's 0.
Isn't it 0 because it starts with x divided by 2x squared, so they're not
Oh,
like
yes. So it's 0 regardless. Yes, I forgot that there was an x squared on the bottom. So it would be 0 regardless. Whether I analyze the original function or whether I analyze this simplified function, it's 0 either way.
And then where would the hole be? If it's x, is it
It's at
0
the other. It's the hole is going to be at the trouble point that got canceled out.
Okay.
In other words, once I canceled the x's, it no longer appears that x equals 0 as a trouble point. But we know that it is. So I'm going to draw my hyperbolic function. That's what it's going to look like, and I know right there is a trouble point.
Okay.
So where's my discontinuities?
-3 and 0.
Yep. And we got our holes and vertical asymptotes. So let's look at 61. We got time for one more.
Okay.
This is a fairly normal looking function, except it's got the minus sign in front of it. What's the vertical asymptote?
4.
There's only one trouble spot, because there aren't two things in the denominator anymore. On all these other problems, we had two factors in the denominator. Well, now we only have one, so there's no holes. There's only a vertical asymptote. Horizontal asymptote is y equals 0.
Right.
And now the only question is whether this curve goes like this, or because of this negative sign, that probably switches. It probably means that this curve goes like this. And if I wanted to figure out what, well, let's make x equals 0. If x equals 0, I have a -3 over a -4, so I'm at positive territory, so I'm right there. So this graph is the correct graph. And you can always determine whether hyperbolic equations are graphed properly by just picking a value that's one side or the other of this vertical asymptote. I picked 0, which was to the left of it. Plugged in x for 0, got positive 3/4, so I know that that point has to be on the curve. So this has to be the graph, not the first way I drew it.
Okay, so the vertical asymptote is 3/4?
No, vertical asymptote is at 4.
4.
It's
Oh,
always
okay.
whatever makes the denominator 0.
Okay.
The rest of my conversation was merely to distinguish whether this graphed in these two quadrants or these two quadrants.
Oh, okay.
And to do that, I just plugged in a value close to that vertical asymptote where I'd be able to tell which quadrant I'm in.
Okay. That makes sense.
All right. This one, factor the bottom, and you're going to have two vertical asymptotes. You're not going to have any holes at all. You're going to have a vertical asymptote at -3 and +2, and the graph will look something like this. Whenever you have two vertical asymptotes, you still have the horizontal asymptote. Usually it looks something like this, and then it does something, usually goes up like that.
Okay.
So there will be a point of discontinuity there. There'll be a discontinuity there at both
Okay.
asymptotes.
All right. Perfect.
Okay.
Okay.
Go to it. Incidentally, let me send you the link right now. Hold on before you sign off. I don't know where it is. Can't easily get it for you in a few moments either. Yes, I can. No, I can't. I was going to just show you, you have a page on this website that has recordings of all of your sessions, all of your online sessions.
Okay.
In other words, if you wanted to review the session today,
Mm-hmm.
to find that link, see if you can find the original email I sent you after our very first online session, where I sent you an email that gave you the link
Okay.
to go to. And then 3 or 4 hours after our session, I post that file as a YouTube video. It looks like this.
Okay.
Okay, and you can review it. And this is one section you might want to review. I mean, we've covered a lot in the last 2 sessions. Between last night and today, we covered a lot of math.
Right.
All right.
Okay.
All right.
Thank you.
I'll talk to you next time. Bye-bye.
Okay.